Hello guys. So the question of the tangent normal. So in this series we discuss different types of questions, and right now we have in this question we have two curves, curve 1 and curve 2. We want to show this, these touch each other. So what does it mean? They touch each other at the same point. This is the point of contact. This is a common point. So at this point, if it is common in these two, so the tangent passing through it is also common tangent. It means the tangent at this curve 1 has the angle theta with positive x-axis, and the same way the angle subtended angle makes with positive x direction of this tangent on this curve is also the same. So the same slope, same angles with positive x axis. So it means dy over dx at these points should be equal. So our task, our focus on the derivatives, first derivatives of these two curves and slopes, and these should be equal. So we are taking the first curve. So it is curve 1. It is xy equals to a square. So on applying the product formula for the differentiation, we get x, differentiation of x is 1 and it is y, plus x as it is, on differentiation of y is dy over dx, and this is a constant part, it will be 0. So dy over dx equals to minus y over x. So on putting this point, common point of contact for this curve in this expression, so it will be this is the slope of tangent, common tangent, on curve 1 at the point of contact, means x1 y1, or you can say point P. So it will be dy over dx at x1 y1 will be minus y1 x, or simply y over x. So this is the slope 1. Now in case of second curve, we have the same common point, and when we draw the tangent, so we get the same tangent, so it is also a common tangent. So right now we will differentiate it. So the equation of second curve so on differentiation we get 2x plus 2y with dy over dx equals to 0, because this is constant. So dy over dx is minus 2x over 2y. So on cancelling this, we get minus x over y. So dy over dx is minus x over y. This is for second curve. So right now, if we want to collect the slope of the common tangent, at the second curve, at the point of contact, that is x1 y1. So on putting this point in this differentiation, dy over dx at x1 y1, this is the slope of second tangent at point of contact, that will be minus x1 over y1. So if we have first line and this is second line, it is like tangent 1 and it is tangent 2, and this is the angle between them. Let us consider theta, or you can say phi. The slope of this line is empty 1, and the slope of second line is empty 2. So the angle between them is phi. Tan phi is m1 minus m2 over 1 plus m1 m2. So we have curve 1, that is xy equals to a square, and curve 2, that is x square plus y square equals to 2a square. We will simplify these two, and we will collect the values. So we put this value in this equation, a square. So we get x square plus y square is 2xy, because xy is a square, so we put the value of a square is xy. It is x square plus y square minus 2xy equals to 0. It means x minus y whole square is 0. So x minus y is 0. So x equals to y. We have this expression, we put it in any equation. So it is like, so it is xy equals to a square, and the value of y is x, so we put x into x equals to a square. So x square equals to a square, so we get x equals to a, you can say plus minus a. And because x equals to y, so y equals to x, that means y is also plus minus a. So the points are a comma a, or you can say minus a comma minus a. This is the point of contact. Now we have the expression of slopes, like uh, tangent 1 on first curve, that is dy over dx at x1 y1 is minus y1 over x1. So the point of contact x1 y1 is a comma a. So when we put this value, so dy over dx at a comma a will be the slope of first tangent. So it is minus a over a, we get minus 1. And in case of second slope, so the tangent second on curve 2, so the slope of second tangent is dy over dx at x1 y1 is minus x1 over y1. So dy over dx at a comma a, or minus a comma minus a also. So you can place plus minus a and plus minus a, but we get the minus 1. And the same way we can place a over a, so you can say plus minus a, both values, any point, positive a or negative, so we get minus 1. So the slope of second tangent is also minus 1 if the slope of two lines are equal. So that shows these lines are parallel. So the tangent 1 and tangent 2 are parallel, and the point of contact is only one, so this is a common tangent. That means curve 1 and curve 2 touches each other. show that the curves x cube minus 3xy square plus 2 equals to 0 and 3x square y minus y cube minus 2 equals to 0 cut orthogonally. So orthogonal means perpendicular. If two curves are perpendicular, that means these curve or you can say the tangent on these curves are also perpendicular. So we have to show the slope of first tangent on the curve 1 and the slope of second tangent on curve 2. The perpendicular of their slopes should be minus 1. If the tangents are perpendicular, that indicates the curves are also perpendicular, or you can say orthogonal. So we have curve 1, that is x cube minus 3xy square plus 2 equals to 0. So on differentiation, we have 3x square minus 3 plus x as it is 2y into dy over dx plus 0 equals to 0. So 3 is also coming 0. So x square minus y square minus 2xy dy over dx equals to 0. So it means dy over dx equals to x square minus y square over 2xy, and at the point of contact, so empty of first tangent will be dy over dx at x1 y1 is x1 square minus y1 square over 2x1 y1. Now the curve 2, 3x square y minus y cube minus 2 equals to 0. So we will use differentiation. We get 3 2x into y plus x square into dy over dx minus 3y square dy over dx equals to 0. So x square minus y square dy over dx equals to minus 2xy. It means dy over dx is minus 2xy over x square minus y square, and the slope of second tangent at point of contact will be dy over dx at x1 y1 is minus 2x1 y1 over x1 square minus y1 square. So this is the second slope. So we have first slope and second slope. If the product of these two is minus 1, that shows the tangents are perpendicular. So first we have to show this. So we have empty 1 and empty 2. So we put these values. It is x1 square minus y1 square over 2x1 y1, and this value is minus 2x1 y1 over x1 square minus y1 square. So cancel this with this and 2xy with this, and we get minus 1. So it shows m1 and second slope, the product of first tangent slope and the second tangent slope is -1. It shows the tangent 1 at first curve is perpendicular to the tangent 2 on second curve. If the tangents are perpendicular, that means the curves cut orthogonally. These two curves orthogonally. So hence proved